Good evening, Professor Ben. How are you doing?
Doing well. How are you today?
I'm doing good, sir. Thank you. So, how do you find the IIT Tirupati campus? I believe this is the first time you're visiting here?
This is my first time to IIT Tirupati, or Tirupati to begin with. It's a phenomenal campus. Everyone's very, very friendly. Facilities are very impressive. I got to see some of the labs. It's a very beautiful campus.
Nice, nice. Have you visited the places in and around Tirupati? Did you get the opportunity?
Yes, I went to 𝗘𝗲𝗃𝗶𝗶. I went to another temple. I don't remember.
Very, very good to know. Thanks. So, regarding the conference, what are the expectations from this conference in terms of shaping the future of construction materials in the near future?
So the future of materials is definitely ever changing in the current climate. We definitely need to be considering climate change, sustainability in, first world countries in the U.S. where I'm from, as well as developing economies, and it's a problem we all face, climate change and sustainability. And so this conference is fantastic because it brings together people from all over the world, not just in materials, but also in structures, and now the actual applications, as well as those of us studying the material scale, and hopes to find a synergistic solution across length scales.
That is true. We are glad that we have you here for the conference. So, in your opinion, which deterioration mechanism do you think is most underrated or underestimated in conventional concrete?
That's a challenging question. Wow. The most underrated or underestimated. Yeah. I would say we designed for all of them, but probably the one that we measure the least are diffusion coefficients for very specific ions. Right? We'll measure something like surface resistivity or RCPT and assume that tells us something about a diffusion coefficient, and therefore design a structure assuming some diffusion coefficient of chloride and then some cover depth and all that. But to actually measure the diffusion coefficient is much more challenging. It's much more labor intensive. There are some newer non-destructive evaluation techniques. I use one of them in my lab that allows us to more efficiently and much faster measure these diffusion coefficients. So while we recognize chloride-induced corrosion as a significant issue, I think the way we go about designing for it makes maybe too many assumptions without actually measuring some of those coefficients.
So that leaves a scope to improve those aspects.
I think there's room for improvement just in terms of we have plenty of standardized tests, but what are they actually telling us? And do they all, as soon as we start changing more and more of these new cementitious materials, we go to LC3 cements, we go to geopolymers, do these same, I'm going to call them index tests, like RCPT, right? Is that index test the same result for all of these concretes? Not all of it is. I think we should be focusing more on direct measurements of something like a chloride diffusion coefficient that we can then put in the model, predict actual, long-term diffusion to predict time of corrosion.
That is definitely something to consider. So the next question is, what emerging materials or technologies do you believe has the potential to shape the enhance the concrete strength and durability, in your opinion?
Okay. Well, we are definitely constantly changing our material scope, right? We're constantly pushing the boundary of reducing our clinker factors. So calcite clays, that's come up a lot in this conference. LC3 cements as well. These are definitely things that are, we're still developing them. I don't think anyone has fully embraced them or using them entirely. We're still stuck with conventional concrete a lot of times. But certain parts of the world, U.S. is one example of just running out of fly ash and coal ash. We need something else. So definitely that's a new emerging market, are definitely some calcite clays, maybe even other SCMs that we haven't really thought about yet. I don't believe there's a global solution to that, right? Calcite clays are not available worldwide. So there are regional locations where we can find it. But it's the same with natural positons, right? That's another one we're not going to find worldwide. Local markets, those you can find. So that's where the material scope, I think, is changing. There's been a lot of very interesting new developments in chemical admixtures. I think that's going to further shape how we develop our materials, right? So we're just looking back at, PCs and plasticizers. Those were developed more, I believe, in the 1990s, right? And the revolution of concrete and the strengths we've been able to achieve from these engineered plasticizers, right? So what's next? What's that next chemical admixture that's yet to come out that's going to revolutionize things? Some of that seems to be driven in part by, yes, for UHPC, things like that. But the world of 3D printing of concrete is also really seems to be pushing the development of those chemical admixtures, those specialty admixtures that are going to, perfect our rheology to make, 3D printing more realizable. I think that's another technology that's developing quite a bit. Is it going to solve all of our problems? No. Are other people promising it will solve all of our problems? Yes. Right. So what will we actually get out of it versus what people are promising? I think we'll see a lot more development in that field. But who knows?
Yeah.
I'm looking forward to see where it goes. Time will tell.
My final question to you is, if you could prioritize one area in construction materials to carry out your research, so what would that area be?
For my career, or just what we should be focusing on?
What should we be focusing in general?
What should we be focusing on more in general? That's a good question. So there's a lot we still don't quite understand about nanostructure of hydrated cement, CSH, CASH. As we go into geopolymers, we have NaSH, NaS shells, right? There's a whole new class of these. To understand the long-term strength and durability of these materials, I think we need to better understand those chemistries, right? Especially now as we're still looking at all of these alternative ICMs, we're now looking at alternative recycled aggregates, these all new chemical admixtures, right? We can't test every permutation that we can think of in every one of these concretes. So we have to start somewhere. Studying CSH itself is sort of the fundamental building block of any cement-based system, but that in and of itself is really difficult to study as well. So I don't know that I have the right answer there. And maybe it's understanding more of these structure-property relationships and understanding, maybe the nanoscale, how that translates to, a much larger structural scale. So, if we can develop better models that can take inputs of any combination of SEMs that we haven't thought of yet, where we would actually prescribe, okay, this is a new calcined clay with a different chemistry we haven't studied yet, plug it into this model, we can predict with CSH, and maybe that's a way to then predict these larger scale properties. I don't know. But I think there's a lot more unanswered questions there. The problem is just resources, and the ability to actually study that material is very difficult. So that's my dream, studying more on CSH, but I don't know that it's recognizable and realizable, in every lab, right? It's a little bit more challenging.
Sure. It was a pleasure meeting you.
Thank you.